In 3.4, we're going to continue to do some word problems with quadratics, and there is a note sheet that is posted online if you want to print that off to take your notes on. Otherwise, you don't have to. But the first thing I want to do is start by reviewing the quadratic formula. It's really expected that you know this by now, but your quadratic formula, first of all, it comes from the quadratic being written in standard form. So y equals a is in front of the squared term, b is in front of the linear term. Okay, so then the two 1, or 0 x-intercepts that can result from this are x equals negative b plus or minus the square root of b squared minus 4ac. And that's all over 2a. Okay, another important thing to know about quadratics is the vertex, because the vertex is what you're going to be finding whenever the problem asks you to maximize or minimize something within the story problem. Now, whether you're finding the max or min, every parabola has a max or a min. Okay, it just depends on the context of the problem, whether it has that max or min. And then it depends on whether this A is positive or negative. If A is positive, then it's concave up and it has a minimum. If A is negative, if you have a negative A, then it's going to be concave down and it'll have a max. But the vertex is the x value is negative b over 2a. And so then the y value is just plugging that into the quadratic. That's a 2. And that is the max or min that all these word problems are asking for. And again, how do you know if it's a max or a min? 1, it might say so in the problem. And 2, the quadratic they've provided you with, look at that leading coefficient. Is it positive or negative? Because that says a lot about the look of the parabola. Okay, so we're going to do 2 examples together. This first one, a farmer has 2,000 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that enclose the most area? Okay, so I'm going to start off by drawing a picture. We know we have 2,000 yards of fence to make this rectangle with. What we don't know is how long this is going to be, but those two will be the same. And we also don't know how long the shorter side will be. We just know that they would be the same on each side. Okay, so we want to maximize the area using 2,000 yards of fencing. A few things when you have these types of problems. What you're going to have to do, notice nothing else is provided. You need to ask yourself, what types of equations can I write with it, given that this is a rectangle? I hope a lot of you know, okay, well, area would be x times y, right? And that's actually what we're maximizing. So then I'm going to ask you, what's another equation you can write for a rectangle? Okay, so I hope you're thinking, okay, well, a rectangle has this 2-dimensional area, but it also has this 1-dimensional perimeter. And the perimeter is x plus y plus x plus y, just adding the distance around. So that's 2x plus 2y. Okay, but some good news about that perimeter is we know that the perimeter is 2,000 yards because that's how much fencing we have. Now I want to pause for a second and just talk about when you're doing these problems, it is very smart to be able to write more than one equation given the variables you have. So, and usually those come from, okay, so I can write this statement for this one-dimensional aspect of this picture, like perimeter or circumference. And then I can also write an equation using the two-dimensional aspects of this figure. Okay, that's the kind of thing you're doing. So perimeter is actually 2,000 equals 2x plus 2y. And what we're going to do with this is I want to be able to write this area equation in terms of just two variables. Right now there's three. There's area, there's x, and there's y. Basically, I want to make it so that there's not both an x and a y. I just want there to be just x's or just y's. It doesn't really matter which one. I'm going to go ahead and solve for x right here. So that means I would subtract 2y and divide by 2. So 1,000 minus y, that's a 0. Still not used to writing on the screen here, equals x. Okay, so then what I'm going to do is, since that's what x equals, I'm going to take this 1,000 minus y, and I am going to plug it in up here for x. Okay, so I would have area is y times x, but this time area is 1,000 minus y times y, which is, I'm going to go ahead and write it as, if I distribute this, I'm going to put the quadratic term first, so negative y squared, and then plus 1,000 y. Okay, so then I find maximizing area. Maximizing the area means vertex. Okay, so the vertex would be negative, so this A is -1 and B is 1,000. So vertex, the x value of the vertex would be -1,000 over 2 times -1, which is -1,000 over -2, which is 500. Okay, so let's take a moment. We just solved for the y value right here, which is an x value, which is kind of confusing. But ultimately, we did just solve for y. Maybe I shouldn't have used x and y, but we solved for y in this problem, and y in this problem is this dimension right here. Yes? So if y is 500 yards, what is x? Well, we're going to go back to this equation right here. X is 1,000 minus y, so x is 1,000 minus 500, which is 500. Okay, so guess what? Oftentimes the area that maximizes a perimeter is the square that can be made from that, as long as the square can be made from that perimeter. So to maximize the area, you're going to do 500 yards, by 500 yards. If, say, I wanted you to find the area that is that maximum perimeter, you would plug it in right here. You'd take A of this y value, which is 500, and you should get, I think I have this over, 250,000 yards squared, okay? So that means this parabola that would look something like this, when you go over 500, you are up 250,000. Okay, another type of problem. a pretty common quadratic problem. I'm sure you probably did these, something like this last year in Algebra 2. A projectile is fired from a cliff 500 feet above the water at an inclination of 45 degrees to the horizontal with a muzzle velocity of 400 feet per second. You can see that 400 feet per second is actually in this formula for height. It is established that the height of the projectile above the water can be modeled by this provided parabola. Okay, so a few things. This 500, that is the y-intercept, okay? Because if x is 0, you're at 500, which makes sense because they say that instead of firing from like ground level, you're firing up here on a cliff 500 feet above the water. Okay, so it fires, this is negative, A is negative, so it's concave down, so it looks something like this. And again, technically the parabola is over here too, but that's not a part of the problem in this context, and technically neither is this, right? Okay, so that's kind of what our parabola looks like. So when it says find the max height, again, you see max or min, that means vertex. Just be careful because the vertex has two parts. So when you see max, definitely want you to be thinking vertex. But again, which part of the vertex is the answer? The x value or the y value? Well, let's find the x value and then we'll talk about what that x value is. Okay, so actually, first thing I want to do is maybe simplify this number. What is negative 32 over 400 squared? I don't know if you need to do this, but negative 1 over 5,000, just to take a note. You don't have to do that, but okay. So the vertex, the x value is going to be negative 1 over 2 times a. Negative 1 over 5,000. Okay, so simplifying that, that should be 2,500. And this is where, I don't know if I made this joke yet in class, but I have this joke that I tell every year about people giving really weird answers when they're doing word problems. Like when I was teaching Algebra 2, I just remember all the time I'd have this question about the height of a candle. And that would be like a linear word problem. And I'd say, what is the height of the candle? And people would say 53 seconds. The height of the candle is 53 seconds. Think about, okay, what is it that you're being asked for? Okay, and what are the individual numbers that you're finding? So when you find this, okay, this x value is not the height, right? Okay, so this right here is your h of x, okay? It's not, we just found the input, okay? So if we want the max height, we need to take h of 2,500, and we would get, I'll give you, pause the video, plug that in. Okay, so, you know, this is what's the 2,500. And then the max height is over here at 1,750. Okay, so very common mistake. People stop here and say that's the max height. You don't get the points. Okay, so how far from the base of the cliff will the projectile strike the water? Okay, we'll go back to your picture. Where does that happen? That's right here. What is that right here? That is an x-intercept. Okay, we know how to find maxes and mins. That's with the vertex formula. But how do we find x-intercepts? Well, that's factoring, or that is the quadratic formula. So we need to find the x-intercept. So x equals negative b squared times a times c all over 2a. So go ahead and pause the video and plug this in. I want to make sure you can do this and see what answers you get. You should get 2 because you got to do this for plus and minus. Okay, so you should get the answers negative 458 and then also 5,458. Okay, so the thing is, this negative 4,000 or negative 458, this is the intercept that happens over here. That's not in the context of the problem. So this is your answer right here. 5,458 feet away from the cliff. Okay, your homework, let's see, why did I noticing that your homework, well, I'm noticing that I X'd, yeah, your homework's not super long, but I have X'd out, it looks like I've X'd out 27, so you just, that's not very long, but if you need help, you can email me, but I'll also have a Zoom on Wednesday. No, not Wednesday. On Thursday at 1 p.m. to answer questions for this homework that's due on Thursday right at 11:59 p.m.